Produce instead of programming. Automated milling with the CAD CAM system pictures by PC. With a few mouse clicks you can produce complex prismatic 3D workpieces on any CNC machine in a very short time. Let's start with a simple workpiece that we import using a neutral step data format. This part is now vertically orientated. In the standard CAM menu we first select the CAM Smart button and then the one for the parameter settings. Here we only check whether a line part is activated. As we have seen, the calculation is completed surprisingly quickly and we then run the milling simulation automatically. The CAM calculation generated around 30 processing steps, which are visible in the CAM structure tree. Initially, machining from all directions is permitted, as if the part was floating in the air. Under no circumstances would the following face machining from below be permitted on a 3-axis machine. Only when the clamping of the workpiece on the machine used has been decided will only the correct processing steps be obtained. Invalid work steps are simply deleted at the end in the work plan, which is sorted by processing direction. Basically, the user has full control over each of the automatically generated processing steps. For example, he can check each milling or drilling process in the path simulation in individual steps. He can also edit or, if necessary, modify each work step. A user-specific parameter file determines which CAM strategies are used and according to which criteria. We would like to take a quick look here just for information purposes. However, we do not want to go into the CAM Smart logic in more detail at this point. We then machine a relatively complex component with a number of stepped pockets and numerous holes. Conventional CNC programming of such a part requires quite some time. Not so with CAM Smart. After just a few seconds we get the result and quickly simulate the processing. The simulation shows us the expected result. However, two important questions still remain. Are we sure that the part was machined completely and without collisions? To check this, we first start examining possible residual material. As you have seen, no residual material is left. The component is therefore completely machined. We are also now checking whether there are any unintentional collisions. As expected, we don't have any component collisions either. Our component can therefore be manufactured without errors. So we did everything right. Nevertheless, we now want to deliberately introduce errors in order to test the checks. So let's zoom in closer to the component, for example to change it later. Now we want to delete the existing corner fillet as a test. If we now initiate another residual material test, we will of course get a result because of the sharp corner. That was what we expected. The test marks the area of the remaining material in color. Since we only wanted to test the effect of the function, we are now reverting the changes. For example, let's introduce a component collision by reducing the diameter of a drill hole. The area of the collision is marked and the processing block in which the collision occurs is listed. Of course we are reverting the changes now. It is now clear why a CAM system always requires CAD software. Finally, let us briefly show drilling using path simulation. For detailed representation and measurement, the path simulation can also be operated forwards and backwards in single-step mode. Of course, as a user you can also subsequently influence the sequence of drilling and milling operations yourself. The next component is a 3D block bordered by tangential curves for the more demanding CNC programmer. The part has some inaccuracies on the order of 0.06 of a millimeter. Before the actual CAM preparation, pictures by PC will automatically repair the part geometry. Because of the parts repair, the CAM preparation took a little longer here than with the previous work pieces. We will only briefly show the result of the simulation here. As you can see, the part is now producible. However, we will postpone the discussion about the correct workpiece clamping here. Now we turn our attention to a small workpiece that includes nearly all prismatic 5-axis technologies. In order to increase the dramaturgy a little, we also want to interpret an edge rounding and a chamfer, as well as the two threads. For example, the first edge is rounded with a radius of 6 mm. And the second edge beveled with a chamfer of 4 mm. In this case, the two threads were constructed precisely, here, M8. If the thread is correctly constructed, the outer surfaces of the cylinders must be colored cyan. With these changes, we can now simply run the automatic manufacturing process. We've already finished the calculation. For example, let's briefly show how these threads are created. In order to actually be able to mill the workpiece in 5 axes, it is best to clamp it vertically. To do this, we rotate the workpiece accordingly, including all CAM processing. For example 3 times around the x-axis, and once around the z-axis. We extend the stock material at the bottom by the necessary clamping length. Of course, we then have to delete the external trimming, indicated by border, in the work plan. Of course, if necessary, we can re-edit each processing step or change the milling sequence in the work plan. The processing can be verified using the simulation. Before the associated NC program can be generated, the retraction planes and the 0 point must be determined. Both are now done automatically and marked visually. Of course, the 0 point could also be edited interactively or selected using crosshairs. In our case, we like to use a Siemens post-processor with G syntax corresponding to G codes. We can send this result directly to the machine. But first we look at the NC data in the editor. You can see the list of tools used as well as the G syntax of the tool paths. The PDF information sheet, in which the most important information for the workshop is documented, is also helpful. The workpiece is displayed graphically and the file name, 0 point, tools used and milling times are specified. So that the component can be milled, the data only needs to be transferred to the machine. Pictures by PC includes all typical post-processors without any additional costs. As you can see, automated production is very easy to handle with Pictures by PC. The prerequisite, of course, is consistent volume data and proven milling strategies adapted to the material and tools. And a suitable CNC machine, 3 to 5 axes. Thanks to Pictures by PC's built-in, object-oriented interpreter programming language, any additional automation can be easily implemented. In particular, with this programming from Pictures by PC, the above process is completely controlled live and the video was created automatically. We are pleased if we have piqued your interest. Do not hesitate to contact us. www.schott-systeme.de, phone, +49 89 348 069, email, info@schott-systeme.de